Okay, let's unpack this. We're diving deep today into some really fascinating source material. It's right at the cutting edge where AI meets healthcare.
Yeah, absolutely.
The big idea we're looking at is how AI is learning to do more than just, understand the words in a medical chat. It's actually starting to see.
That's the core of it. For this deep dive, we've been digging into recent research from Google. It focuses on their diagnostic AI, which you might have heard of. It's called AME.
AEI,
Right,
the Articulate Medical Intelligence Explorer.
exactly. And our mission here is to really unpack what this new development means, how AME is learning to bring in and understand static visual stuff, things like medical images, documents, right in the middle of a clinical conversation.
And the sources you've dug up give us all the details, don't they? The tech behind it, how they tested it, and maybe the most interesting part, some genuinely surprising results from those tests.
Oh, definitely surprising.
It really paints a picture, maybe, of a future for AI in healthcare. But, one with some big caveats we absolutely have to talk about.
For sure. Crucial caveats.
Now, this idea of an AI assistant you can chat with,
Yeah.
it's not totally new, right? AMIE already made waves with text-based medical chats.
That's right. The earlier work, published in Nature, actually showed real promise. An AI that could handle symptoms, get patient history, suggest diagnoses purely through text.
Which was impressive in itself.
It's a really significant step, yeah.
Yeah.
Building an AI that could have that kind of nuanced clinical style conversation purely through text, that was tough enough.
Right?
But as anyone who's ever seen a doctor knows, real medicine isn't just about words, is it?
Not at all.
Think about how much is visual. A dermatologist needs to see the rash.
Yeah.
A cardiologist looks at the ECG printout. You hand over lab results, or maybe, send a photo of swelling in a telehealth call.
Absolutely. If an AI could only work with a description of a rash, well, it's working with one hand tied behind its back, basically.
Totally.
It couldn't ask you to, zoom in or compare to another spot or interpret that really critical visual data that a human doctor uses instantly.
Right, that visual piece, it was a massive gap for any diagnostic AI aiming to be genuinely useful in the real world.
Makes sense.
Precisely. So the big question for this new research was basically, can we take these advanced language models, the brains behind AI like AAE, and upgrade them? Can they handle a proper clinical chat where they successfully use and understand this more complex info like static images and documents?
And this is where they apparently made a pretty big leap.
It seems so. The core of this new work, laid out in the source material, is all about giving AMI exactly that ability, letting it bring in and understand those static multimodal inputs, images, documents, and weave them naturally into the conversation flow.
How did they do that, technically?
Well, they significantly upgraded AMA. They started with the Gemini 2.0 Flash model, which is already pretty powerful, but they added this key component, something they call a state-aware reasoning framework.
Okay, state-aware reasoning framework. Sounds a bit complex. Can you break that down simply?
Yeah, let's try. Imagine a human doctor talking to you. They aren't just ticking boxes off a list, right?
Right.
They're constantly thinking, okay, what have I learned so far? What's still fuzzy? Which diagnoses look more likely now? And what info do I still need to figure this out?
Ah, okay, so they're aware of the state of the diagnosis process.
Exactly. That's being state aware. This framework gives the AI a similar sort of capability. It understands the current state of the conversation, what it knows, how sure it is, and crucially, what's missing. And that missing piece might be visual data.
Got it. So it helps it figure out what it needs next, including maybe asking for an image.
Precisely. It's not just reacting to your last message, it's keeping track of the whole picture and thinking about its own knowledge gaps.
Okay, that makes sense.
And this state-aware reasoning is really key for handling the visual stuff. It lets Amy figure out when it needs visual information.
So it can ask intelligently.
Yeah, it can proactively request it. Like, could you share a photo of that rash if you're describing a skin issue? Or do you have those lab results handy if you mentioned tests?
And then the hard part, actually understanding what it sees.
That's the really tricky bit. It needs to accurately interpret the image or document, then integrate that new finding smoothly back into the chat, and then use it to update its understanding and its list of possible diagnoses.
Yeah, I can sort of picture how that conversation might go now. It starts with the history, symptoms, timings.
Right. The basics.
Then as it builds a picture, its state-aware function kicks in and goes, a description is okay, but seeing it would be way better.
Exactly. So it prompts you, thanks for describing that. To understand better, could you maybe upload a clear photo? Or if you mentioned tests, Would you mind sharing those results? Seeing the actual numbers would be really helpful.
And it's not just a flat back and forth.
No, the idea is it moves through phases, kind of like a real consultation.
Yeah.
History taking, then more targeted questions, then moving towards diagnoses and management ideas, maybe follow-up.
And at any point, if a picture or a document would help.
The AI, thanks to this framework, knows to ask for it and knows how to process it when you provide it. That's the goal.
Okay, building an AI like this is one thing, but testing it, that's a whole other challenge, especially in medicine. You can't just let it loose on real patients right away.
Absolutely not. Safety and thorough evaluation were clearly huge priorities here. Before any humans were involved, they built this really detailed simulation lab.
A simulation lab.
Yeah, a place where they could test and tweak the AI's ability to handle multimodal data in a totally controlled way.
What did that involve? How do you simulate a medical case with images?
It's pretty complex. They created highly realistic patient cases. They took actual medical images and data like skin photos from datasets like SCIN or ECG data from databases like PTBXL, real stuff.
Okay.
Then, to make them feel like actual patients, they added plausible backstories, symptom descriptions, often generated using their other language models like Gemini.
So you get a full package, symptoms, history, and the relevant realistic medical images or documents for that specific case.
Exactly. And within this simulation lab, they could have the multimodal AMI chat with these simulated patients. The system could then automatically check AMI's work
Automatically, how?
against predefined criteria. Like, how accurate was its diagnosis compared to the known diagnosis for that case? Did it use the visual info correctly? And really importantly, did it make errors? Did it hallucinate things that weren't actually in the images?
Okay. That allows for quick testing and fixing.
Right. Rapid iteration and refinement in a safe space.
But simulation, even really good simulation, isn't the same as talking to a real person. How do they test it more like, well, more like a real interaction?
That led them to the next stage. A more rigorous controlled study using something called a virtual objective structured clinical examination, or OSCE. It's a standard method in medical training to test clinical skills.
A virtual OSCE. Okay, walk us through that study. What was the setup?
They designed this remote study with 105 different medical scenarios, a real mix of common conditions, including ones where visuals are crucial, dermatology, cardiology, things like that. But instead of just simulated case files, they used real actors. These actors were trained very carefully to portray each specific patient case consistently.
Trained actors as patients. Got it.
And these actors interacted through a text-based chat interface. Some chatted with the new multimodal AME, and others chatted with actual human primary care physicians, real doctors.
The comparison group.
Exactly. And crucially, that chat interface let the patient actor upload images or documents, just like you might in a real telehealth situation.
So actors having text chats. Same scenario, some with AI, some with human doctors.
That's the core setup. Then, after each chat, the whole interaction, the transcript, the images, everything was reviewed and scored.
Who did the scoring?
Two groups: specialist doctors, dermatologists, cardiologists, internal medicine docs, depending on the case type, and also the patient actors themselves giving their perspective.
Right. What were the specialists looking for? What were they scoring the AI and the human doctors on?
A whole range of things. How thorough was the history taking? How accurate was the diagnosis, including the quality of the differential diagnosis list? That's a list of possible conditions.
Right.
Also, was the management plan sensible? Did they spot urgent situations correctly? And of course, a really key point, how well did they actually interpret and use the visual information that images and documents provided?
That makes sense. And the patient actors, what was their focus?
They were rating it from the patient point of view. So things like clarity of communication, did they feel listened to? And maybe surprisingly, they were asked to rate things like perceived empathy and trustworthiness.
Empathy and trustworthiness.
Sorry.
For an AI. Okay, you hinted earlier the results were surprising. So after all this simulation and this big virtual OSCE study comparing AME to human doctors, what did they actually find?
Yeah, this is where it gets really interesting, though we need that context again. In this specific controlled study environment, the virtual OSCE with the trained actors AMIE didn't just do okay. In many cases, it actually performed better than the human primary care physicians it was compared against.
Better. Seriously. Better across the board.
Yeah.
That sounds huge.
Well, across many of the key metrics they measured within the specific study design, for instance, interpreting the visual data, the images and documents, the core new skill, the specialist reviewers, actually rated the AI as being better at it than the human doctors.
Wow. Okay, wait. The AI was rated higher at understanding the pictures and documents than the human doctors in these text chats.
In this study, yes.
Oh.
And it seems like being better at handling that visual data helped its overall diagnosis. AME scored higher on diagnostic accuracy, too.
Meaning it was better at figuring out what was wrong.
The differential diagnosis lists it came up with, that rank list of possibilities, were rated by the specialist doctors as being more accurate and more complete compared to those from the human PCPs in the study.
So the expert docs looking at the outputs felt the AI did a more thorough, more accurate job in these specific controlled scenarios. That was the finding, yes. And it wasn't just on diagnosis. Specialists tended to rate AME higher across most areas. They looked at the quality of that image interpretation, how thorough the workup was, the soundness of the treatment plans, spotting urgent issues. The AI generally scored higher in this setting.
That's pretty staggering from a technical perspective. But what about those softer skills? Empathy, trust. Surely the human doctors won out there, even in a text chat.
And
Yeah.
this might be the most surprising finding in the source material. The patient actors, the people playing the patients, they often rated the AI as being more empathetic and more trustworthy than the actual human doctors in these text interactions.
Hold on. More empathetic, more trustworthy than a human doctor from a chatbot. That really challenges a lot of assumptions about, the human touch in medicine. It definitely makes you pause and think. Now, again, context is absolutely critical here. It was text only. The patients were trained actors rating specific things. Real doctors work in much richer ways.
Right.
But the finding itself is still provocative. Why might that happen in this study? Maybe the AI's consistency, its structured approach. Maybe it never sounds rushed or frustrated, unlike a busy human sometimes might, even in text. It's politeness protocols.
That's actually a really interesting thought. Maybe in that limited text environment, some things we perceive as empathy or trust, like consistency, politeness, thoroughness, and AI, can deliver really reliably, maybe even more reliably than humans sometimes do in that specific format.
It could be. It's not that the AI feels empathy, but maybe its communication style in this constrained setting was perceived more positively by the actors.
Fascinating. What about safety? Errors? Hallucinations? Especially with images, that seems like a big risk. Did the AI make more mistakes seeing things that weren't there?
A critical point. They specifically looked at image-based errors, like the AI misinterpreting an image or seeing something that wasn't real. In this study, they found no statistically significant difference in the rate of those kinds of errors between AMIE and the human doctors.
Okay, no statistically significant difference in this study. That qualifier feels really important every time.
It is incredibly important, and Google is very upfront about the limitations, which is good. They even mentioned some very early internal tests using owner model, Gemini 2.5 Flash, just in their simulation lab,
Oh.
showing further improvements.
The simulations hinted at potential improvements in diagnosis and management plans, yeah.
Ah,
But they stress these are just automated simulation results. They absolutely need rigorous review by expert doctors to confirm if those benefits are real. It really underscores this is still research. Okay, so we've got these really impressive, maybe even startling results from the study, especially on visual interpretation, diagnostic accuracy, and those surprising actor ratings on empathy and trust. But let's hammer home those limitations again. What are the big reality checks here? This wasn't AME in a real clinic, right?
not even close. And the researchers state it very clearly themselves in the source material. They say this study substantially underrepresents the complexity, the unpredictability, and the richness of real-world care.
Substantially underrepresents the complexity. That's pretty blunt. What does that mean practically? How is a controlled test with actors so different from a real clinic?
Well, just think about the sheer messiness of reality. Real patients don't present neat symptoms. They might have multiple conditions at once, interacting in weird ways.
Yeah.
They might struggle to explain things clearly, forget important details, or have really strong emotions, fear, anxiety, pain, that actors, however good, just can't fully replicate.
And the way they communicated was limited too, wasn't it? Just text and static images?
Exactly. The source makes that point. Text-based chat, static image uploads. That's so different from a face-to-face visit where a doctor sees your body language, hears your tone, all those subtle cues. Even a video call gives much more info.
Right. You lose all that nuance.
All of it. So, while these results in the controlled virtual setup are genuinely promising and show what the tech can do,
They're not saying this AI is ready to replace your doctor tomorrow.
absolutely not. It's not a direct prediction of how it would perform out in the wild today, dealing with real, complex human health issues. It's a powerful proof of concept showing the potential, but It's definitely not a ready-to-deploy tool for unsupervised care.
So given those big limitations, what's the next step they mentioned? How do they plan to bridge that gap between the lab and reality?
The crucial next move is taking it carefully out of the lab and controlled studies into actual clinical settings. The course mentions they've planned a research partnership with Beth Israel Deaconess Medical Center.
Okay, a real hospital.
Yeah. The goal there is to see how AMI actually performs in real clinical environments, with real patients obviously under very strict research rules and with full patient consent.
That sounds like the essential step, seeing how it handles the unpredictability of real patient care.
Absolutely. It's the only way to truly understand its strengths, weaknesses, and safety in the places it might eventually be used. And the researchers know that to be really useful, especially with telehealth growing, these AIs will eventually need to handle real-time video and audio too, not just text and static images.
Which is another big technical challenge down the road.
For sure.
So what we're really seeing here is this exciting step forward, AI getting the ability to see and reason with visual medical data during a conversation. It definitely gives us a compelling glimpse of a future where AI could be a powerful assistant, maybe helping doctors with diagnoses or helping patients understand information.
It's definitely a significant leap for multimodal diagnostic AI. The results from the simulation and the controlled study are impressive, showing potential advantages in certain areas under certain conditions.
But, like we've really stressed, you have to ground that excitement in the current reality. This is research. It was tested under specific circumstances. The path to safely and effectively using tools like this in everyday healthcare. It's still long, it's careful, and it needs a lot more real-world testing.
It's a promising horizon, absolutely, but it's not today's reality just yet.
Leaves us with a lot to think about, though.
It certainly does.
It really does. This deep dive into AME's visual skills shows just how fast AI is evolving to handle complex information, including those visuals that are so vital in medicine. We've seen the tech leap, the surprising results in controlled tests, even around things like perceived empathy, but also that clear-eyed view of the limits and the cautious path forward.
Yeah, it highlights the potential for AI to help both clinicians, maybe by catching subtle visual clues or refining diagnoses, and maybe patients too, by giving initial assessments that are better informed by the visual info they share.
So what does this all mean for you listening right now? When you think about an AI that can see medical images in a chat, what does that suggest about the future relationship between you, your doctor, and AI?
Hmm.
Can things like trust and empathy really be simulated, or maybe even perceived as enhanced by AI in healthcare chats, like those actor ratings suggested? And looking ahead, how might integrating an AI that sees actually change what a doctor's visit feels like, whether it's in-person or remote?
These are really profound questions, aren't they? And this kind of research pushes them right to the front. They'll definitely shape how we think about and adopt AI in health going forward.
We would genuinely love to hear your thoughts on this. What stood out most to you from our deep dive into AMI's new visual skills? Let us know your opinions, your suggestions down in the comments below.
Yeah, please do.
And if you found this deep dive interesting, if it gave you something to think about, please give this video a like. It really helps. Also, subscribe to the channel and hit that notification bell so you don't miss our future deep dives.
And maybe share it with others who might be interested in how AI is changing things, especially in healthcare.
Absolutely.
You
Let's help
too.
spread the conversation. Thanks for joining us.